This is the resist, this is the radius R, 2R, and a resistance R is connected. So at t equals 0, I'm writing the situation. What was the charge here? Q1 minus Q1. This will be Q1 plus Q2. This will be actually the charges, no? So they're thin shells. It doesn't matter. Okay, let's assume that one. Charge on all surfaces. And we know potentials, like how we say potential of A equal to KQ1A plus KQ2 by B. Potential of outer shell KQ1B plus KQ2B. So therefore this potential VAB is what is equal to KQ1 B minus A by AB. R and 2R, okay, that let me write here. This will be 2R minus R. Okay, this is the potential KQ1 by 2R. No, VA greater than VB. So what will be the charge? Okay, the charge will flow from inner to outer shell. This is the thing. So now, but what is the question asked here? Find the current passing through the switch. Is asking to get that current. So finally, after some time, what will be the situation? The situation here it will be radius R. This is 2R. This is thing. So the charge here, let it be Q. The charge here will be minus Q, and amount of charge here will be Q2 plus Q. At any instant of time, okay, fine. So this is R. So it's asking to get that current I. So current I, I'll show it. So this current I, this is at any time T. I think now you are into the problem. With a shell A, B. How to, so we can find out that it generated all other things, but it's asking expression for the current. So what I do is I'll just make things very simple. So where the plate A is connected. So is there any capacitance between A and B? Yes, there's a capacitance between A and B, and also there's a capacitance from B to C. From B to infinity also, there are two capacitors are there. But where the resistor is connected, the resistor is connected across A and B only. So therefore, this will be the circuit R from A to B, Q minus Q, and from here the plate B, it is another thing connected to infinity. I'm not bothered because where do current will flow only in this. Is that okay? So this is the overall circuit here, and this is the
Sir, can
capacitance.
you
So
repeat how did you draw that?
there's a capacitance between A and B, and B and infinity also, surface B and infinity, but where the resistor is connected between A and B. So I think I should draw the suitable diagram like this. Okay, it's clear now. This will be, and the charge will flow from inner shell to outer shell through the resistor R, and there is no need of this one CB infinity. It will not come into picture. Don't think that it will not have this one. It will be there, but it will not come into picture here. So we want this I now. So it's as good as like a discharging circuit, no? But we don't know capacitance CAB. How to bring that? How to bring the capacitance CAB?
Q by VAB.
No, this one. Physical dimension. CAB is nothing but
4
equal
pi
to 4.
epsilon naught to R minus R by 2 R into R.
So already you know that if two concentric shells, what is the capacitance? So 4 pi epsilon naught 2R minus R by 2R into R.
I think it is reverse.
Reverse. 2R into AB, F4 pi epsilon naught AB by B minus A. Yeah. This much. This is the capacitance. So now we know capacitance, we know that initial charge, everything. So let's go for directly RC circuit concept. It's or no. The initial setup, what you have to do it. So here I'll write down the equation now. The loop equation will be plus Q by C minus IR equal to 0. And what is I? I should be equal to minus dQ by dt. Any reason for that? Discharging, no? I'll write one more step. So I equal to minus dQ by dt. Q by C. So directly, I think I can write expression. Okay, we have to put limits now here. What should be the limit? Minus dt by RC. At t equals 0, what was the what you should take limit? Q1, Q2 both are there, no? I'll bring the diagram. All Q1, Q2, everything is there. So what should be the limit? We have to take it. So what is the charge of capacitor? Charge on the positive plate, inner surface of positive plate of capacitor. What was the charge there? It was Q1, no? This Q1 is what? The charge of capacitor. Got this? So what was the initial charge? Q1. Finally, how much it will become? The whole charge from inner surface, from shell A to shell B, it will go. So therefore, the charge, the limit should be Q1 to Q. So get expression for Q, then you differentiate. It will be like this. So log of Q is equal to Q1 e to power of minus T by RC. This you differentiate, you'll get the expression for current. And in place of R is given, C what happened, you should write this equation. So the I is equal to dq by dt. So let me differentiate this. Dq by dt equal to Q1 by RC. Eight pi epsilon naught R this is the expression for current. Just be careful. So the in the Van de Graaff generator, the charge will not flow instantaneously. I think you look at the experiment. It's there in the. It come in lab actually. So when we discuss the experiments, no, there we'll discuss in detail that one. But there's the basic picture. So just be careful. Some concepts of electrostatics. So what happened? What we learned there, no, that we are going to conclude here. The same problem, it is there in the Pathfinder. Instead of giving charges Q1 and Q2, no, he has kept a charge at the center of this shell. Okay, got this. And instead of this resistor R, he has filled up a medium. So you know resistance of a thick shell. bring that one again. Try to use the same concept. The expression will be like this only. Next, what is asking? The charge induced on the outer surface of that one. It's a very beautiful problem. I think with this